Hi, I'm Cullen. Welcome back to Module 7 of Networking Fundamentals. We're going to go ahead and start detailing today the TCP IP protocols and using them in the command line. Let's go ahead and take a look at our agenda. We're going to cover Objective 3.6, understand TCP IP, and we're going to do that through protocols, right? And this really is going to detail more so how to use the protocols and what each of the protocols does. I still recommend that you do a lot of intensive research on each of the protocols. Each could be their own course. But that being said, we're going to focus on the command prompts, how to use that, just some basic TCP IP commands, and then some more advanced commands as well. Okay. All right, so the command prompt. The Windows command prompt, it's just a command line interface. Running it as an administrator is known as running it in elevated mode. You're probably going to hear this commonly. It's not something that you necessarily need to concern yourself with for this networking fundamentals exam, but it is something that you will want to know, especially if you want to take any other Microsoft-based courses. Many tools, tons and tons of tools can be used on the command line. And so let's go ahead and actually just take a quick look at the command line itself. So here's the command line on this computer that I'm working on right now. You see it's real simple. It's the command line interface, text-based. You're not going to see any graphics. It's just text and characters and digits, right? Pretty simple stuff, but very, very powerful still. So, all right, let's roll into TCP IP commands. We'll start with the basic ones. ipconfig. ipconfig is super useful. It displays the current configuration of your installed IP stack, right? If you use it with the /all switch, it'll give you a lot of additional information. And that's actually what you see here on the right-hand side of the screen. So that is the ipconfig space /all command in action. It can also be used to refresh your DHCP, your dynamic host configuration protocol, and also change domain name system settings. Okay, just real fast, let's just go ahead and see that in action. If I do ipconfig, note here that we had quite a bit of information come up. You can also check your IP address. So here we have just a link local address, right, and a PIPA address, which starts with 169. We do have our IPv6 address as well here. And then we also can see that we're on a Class B subnet. That's pretty exciting stuff, okay? At least for this emulator internal switch, right? We also have our wireless LAN adapter, the local area connection. Media is disconnected there. You can see that we have an Ethernet adapter, our IPv6 addresses here as well. IPv4 address, this is what we're using to communicate on the network and on the internet. And then here's our subnet mask, right? So you can see VLSM is in action here as well because it's not 255, it's 254. Something that we're not necessarily going to detail, but very cool anyway. And of course, look at all these adapters. We just have tons and tons of them available for us, which is great. If I use ipconfig /all, I get even more information. So really, really detailed stuff allows us to see a whole lot about our TCP IP stack. Okay. All right. So let's keep on moving along here. Ping. Ping is another one that you're commonly going to hear people say, hey, can you ping me later? Or, oh, I'll ping you. That means that what they're going to do is they're going to send you a quick chat or a message. And computers have their own form of that, and that's why people say, I'm going to ping you later, right? What ping does is it verifies IP level connectivity to another TCP IP device by sending an ICMP echo request message. So pretend that this little message right there, the little bit of data, is an ICMP echo request. What's going to happen is that the other computer is going to send it back, and you're going to see that the connectivity exists between those two devices. Okay. All right. Next is traceroute. And actually, you know what? Let me take a step back here. Let's see ping in action. No better way to figure out how this stuff works than to see it in action. So I'm going to go ahead and copy the IP address for Bing. And we're going to go ahead and ping Bing. Of course, I totally forgot. You can't use Control-V on the command line. You have to actually right-click and then paste. And so check it out. We just pinged Bing. And we sent 4 packets. We received 4. We lost 0. But check out how fast that was. The minimum time was 1 millisecond. Maximum was 2 milliseconds. That's just insane for a round trip. If you don't believe me that we were using Bing, I'm going to show you. So if I'm going to open a new tab so you can see that I'm honest, and I'm going to go ahead and paste in the IP address there. If I hit enter, look at what comes up. Bing. Pretty cool. Pretty cool stuff. All right, so let's go ahead and head back to the presentation here. Next one's traceroute. So tracer T is what it looks like, but we call it traceroute. It determines the path that data is going to take to a destination, typically across the internet or across a wide area network, by sending those same echo requests that we use with ping, but they have an incrementally increasing time to live field value. So there's a little extra data attached to those ICMP echo requests. Okay, we use it to trace the path data takes from sending to a receiving device. So what it looks like is here we have quite a few different routers, right? We have 2, we have 3, and then we have 4. And so what we do is we use traceroute to trace the route by hops that it takes to get from one device to another. Okay? Let's take a look at traceroute in action. And we're going to go ahead and trace the route to Bing. And there it goes. And so it's going to show us all of the different routers that it's going to connect to in order to access Bing, right? So it's going to keep on going here. I'm going to hit Control-C to exit out so that we can go ahead and keep on going with our presentation here, okay? All right, so we talked about some of those basic commands. Let's talk about some of the advanced commands now and get into the nitty-gritty. First off is netstat, okay? Netstat's going to display active TCP connections. So any connections that are currently active between your computer and another computer using the TCP protocol, right? With some specific parameters, so different characters that are added on to the end of netstat, or rather additional characters that are provided after a space after netstat. This command can be used to display not just the active TCP connections, but ports on which a computer is listening, Ethernet stats, the IP routing table, IPv4 statistics, and then also IPv6 statistics as well. So let's see that in action really quickly here. Netstat. And I've got nothing. Nope, there it is. So here I've got a couple of different active TCP connections. Oh, there's the rest of them. Pretty cool stuff. Right. Okay. Moving back on to the presentation here. NBTstat is a command that's going to display net BIOS over TCP IP statistics for local and remote computers. Net BIOS name tables, and then also the net BIOS name cache. If you use it with the -n switch, rather separate it and type NBTstat space -n, then you can go ahead and see the names of all the computers on your local area network that you've communicated with. So if we head back over to the command prompt, let's try that out. NBTstat /n, And look, we have our computer names, right? Pretty cool stuff. NetBIOS is responsible for giving a logical name to your computer, so you can call it computer 1 versus, calling it, 192.168.1.10, calling it by its IP address or something along those lines. All right, so back to the presentation. Path ping. Path ping is a command line route tracing tool, very similar to traceroute, except it gives you a little bit of extra information, right? So it combines all the things that you love about ping and traceroute, but it gives you a little bit more info. Okay? Path ping just shows you the degree of packet loss in any specified router, and it really gets in some good detail. It actually will compute results in regards to each hop based on the packets returned from each router that your data visits on its route to its final destination. So really, really cool. It allows you to evaluate things really in depth. All right, let's go to the next one, NS lookup. Right. We display information with NS lookup that you can use to diagnose domain name system problems, and actually should have problems here at the end. I don't know how that got cut off. Right, so we can use it to troubleshoot. The NS lookup command line tool is available only after you have installed TCP IP, so you should definitely be familiar with DNS before using this tool, as well as with TCP IP. And let's actually see if we can use NS lookup on this computer. It's not mine, so if it doesn't work, don't get mad at me, okay? Let's see what happens. So there we go. I do have a default server, and there's the address of it. All right, so TCP IP was enabled. Good job, Microsoft. All right, back to the presentation. Next, we have net shell, netsh, right? A command line scripting utility that enables you to display or modify the networking configuration of a computer currently running. It provides a scripting feature that allows you to run a group of commands in batch mode against a specified computer. That's really it. I strongly encourage you to go ahead and take a look at the netsh command whenever you have a chance. Once again, take a look at TechNet. TechNet's an awesome resource if you have any questions about any of this information. Okay. All right. The route command. Let's take a look here at our presentation. You can use it to display and modify entries in the local IP routing table. So your computer has a routing table, your local host has a routing table, and you can combine it with the route print command to display the routing table for a Windows machine. This is going to give you the same results as the netstat -r command, but it's a little bit more commonly used. So you can also use it to add and delete static routes. So let's take a look at this one in action. So if we type route by itself, let's take a look at what comes up here. Let me go ahead and go full screen. So there's a lot of really, really good information here. Right, so once again, you use it to manipulate network routing tables. So you can clear all of your routing tables, which I don't recommend. Right, you enforce the using of IPv4. -6 forces the using of IPv6. You also have a couple of different commands like print, right? So print's a route. Let's go ahead and take a look at print in action since we did mention it. So here's the routing table for your local devices, right? You have different interfaces too that you're printing these out for, but lots of good information. You got your network destination, net mask, gateway, interface. And you also have a metric that's associated with each one. So that metric's used to determine how you route packets on a network. Talk about that a little bit too. And finally, here we have the net command. And Although not specifically part of the TCP/IP command set, the net command can display various important networking data, and it does enable you to configure various networking options, such as services. So once again, strongly encourage you to go ahead and learn a little bit more about this command as well. Finally, we do have telnet. Telnet enables you to communicate with remote computers that are using the telnet protocol. And so you can run telnet in order to make a communication, or in order to establish communication with the computer. So if I, say, wanted to go from this computer and I wanted to access and utilize, or rather access resources, or access this server over here in the top right corner, I can use telnet to access it, right? You also have a bunch of different telnet, or rather the telnet prompt will show up when you're using telnet, and you can use a bunch of different commands along with telnet in order to manage a computer using telnet. So sorry for the redundancy there. A little bit difficult to word this stuff quickly sometimes. All right, so a network administrator is going to use the telnet command with an IP address. So if I went back and I tried to use Bing, use Bing's IP address, I would not have any success with trying to remotely connect to that computer or to the web server, because I'm not going to have the credentials or the authority to be able to access it, right? Typically, telnet is used with passwords and usernames, and so it's just really important to keep that in mind, that you're going to need to actually have the credentials and the authentication values to be able to access a device remotely using telnet. Another thing to keep in mind too is that telnet is frankly just an older, out-of-date protocol. And so we've actually switched over to something called SSH, Secure Shell. And so we use that now instead of telnet, but telnet is still in use, and pretty widely so, if I'm not mistaken. I actually teach it to my students still, so if you're learning it, feel pretty good about that, okay? Still important stuff to know. All right, so that's the end here. Objective 3.6, understanding TCP/IP through the command line. We talked about the command prompt, showed you some basic TCP/IP commands, and discussed a couple of advanced ones as well. Once again, strongly suggest that you go ahead and take time to do your research with these commands and actually take some time to use them. Experimentation is the best way to learn sometimes. Just remember not to break anything, and if you do, it's not my fault. Thanks again for joining me. I'll see you soon, okay? Bye.